Welcome time-traveling enthusiasts and seekers of wisdom. Gather round as we embark on another thrilling voyage through the annals of history. I'm your guide, David Lee, and this is Timeless Talks. In this personal Who is Who episode, we're about to unlock the secrets of an extraordinary mind, a master of electromagnetism, and a pioneer who reshaped the world as we know it. We have the incredible honor of delving deep into the life and mind of the illustrious Michael Faraday. So, without further ado, let's get started. Michael, would you please introduce yourself to our audience?
Greetings, I am Michael Faraday, born on September 22, 1791, in Newington Butts, a district in Surrey, England. My upbringing was rather humble, as I came from a family of little means. As a young lad, I found myself fascinated by the workings of the natural world. Growing up in London, I was exposed to various scientific demonstrations and lectures, which ignited a spark of curiosity within me. In my early years, I was fortunate to secure an apprenticeship as a bookbinder, but my insatiable thirst for knowledge and my insistent curiosity soon led me to attend scientific lectures and read scientific books during my free time. This journey of self-education opened new horizons for me, and I became deeply intrigued by the then emerging field of electricity. In 1812, I had the privilege of attending a series of lectures by Sir Humphry Davy at the Royal Institution, where I eventually secured a position as his chemical assistant. This marked a pivotal moment in my life, as it allowed me to fully immerse myself in the world of science and set me on a path of exploration that would ultimately lead to my groundbreaking discoveries in electromagnetism and electrochemistry. Throughout my life, I resided in London, where I conducted numerous experiments, carefully observing and analyzing natural phenomena. My scientific journey has been filled with ups and downs, but with unwavering determination, I dedicated myself to unraveling the mysteries of electricity and magnetism. I believe it was this dedication, along with the support of mentors and colleagues, that ultimately propelled me on the path to becoming one of the pioneers in the history of science. And now, it brings me great joy to share my experiences and knowledge with you all here at Timeless Talks.
You've had an extraordinary journey from being a self-taught bookbinder's apprentice to becoming one of the most influential scientists in history. What drove you to pursue a career in science, and how did your humble beginning shape your perspective?
My passion for science was kindled by a sense of wonder and curiosity that I carried since my youth. As a humble apprentice, I had the privilege of reading scientific books during my spare time, and each page turned seemed to unveil new mysteries of the natural world. The simplicity of a candle's flame, for instance, fascinated me and sparked a desire to explore further. My early encounters with science lectures and demonstrations in London opened my eyes to the possibilities of understanding the universe through experimentation and observation. It was during this time that I was fortunate enough to attend Sir Humphry Davy's lectures, and his brilliance ignited a flame of inspiration within me. I realized that my path lay in unraveling the secrets of nature, and I embarked on a journey of self-education and experimental exploration. My modest upbringing taught me the value of perseverance and the significance of hard work, shaping my approach to scientific research. From my bookbinding roots to my rise as a scientist, I remained grounded and approachable, as I firmly believe that science should be accessible to all who sought knowledge. My curious and thoughtful nature led me to meticulously design experiments and analyze data to understand the fundamental laws governing electromagnetism and electrochemistry. In essence, my humble beginnings cultivated a passion for science that fueled my insatiable curiosity, guiding me towards groundbreaking discoveries and a commitment to share the wonders of science with the world.
Your discoveries and contributions to the world of electromagnetism were groundbreaking, but some critics have questioned your mathematical abilities. How do you respond to those who believe your lack of mathematical formalism hindered the full recognition of your achievements?
It is true that I did not possess the same mathematical prowess as some of my contemporaries. However, I firmly believe that scientific inquiry is a journey that can be undertaken by different paths. My approach to understanding the natural world was rooted in experimental observation and qualitative reasoning. While I may not have wielded complex mathematical equations, my strength lay in my ability to envision and conceptualize the fundamental principles behind physical phenomena. Through my meticulous experiments and careful observations, I sought to uncover the underlying principles that governed electricity and magnetism. It was this hands-on approach that allowed me to make groundbreaking discoveries, such as electromagnetic induction, which laid the foundation for modern electrical technology. Though I may not have been a master of advanced mathematics, I collaborated with other brilliant minds of my time who possessed such expertise. My friend and colleague, James Clerk Maxwell, later mathematically formalized many of my ideas, cementing their significance in the scientific community. I never sought personal recognition or glory. My passion was to understand the mysteries of nature and to share my findings with the world, regardless of the formalities of mathematical equations. The beauty of science lies in its diversity of approaches, and I am grateful that my work continues to inspire and spark curiosity in the minds of future generations.
You once said, "Nothing is too wonderful to be true." This optimistic outlook seems to have guided your scientific endeavors. Can you share an instance where this belief fueled your perseverance during difficult times in your research?
Indeed, those words hold a special place in my heart. Throughout my scientific journey, I encountered numerous challenges and setbacks, but my unwavering optimism and curiosity are always my guiding lights. One such instance that comes to mind is during my investigations into electromagnetic induction. At the time, this concept was relatively new and not widely understood. I faced skepticism and doubt from some of my contemporaries, who questioned the feasibility of harnessing electricity through magnetic fields. Yet, my belief that nature had hidden wonders waiting to be discovered spurred me onward. I designed a series of meticulous experiments, testing various configurations and conducting countless observations. As the days turned into nights, I remained patient and persistent, never losing faith in the potential of my inquiries. Eventually, through my methodical approach and unwavering perseverance, I witnessed the mesmerizing effects of electromagnetic induction, the generation of electricity from magnetic fields. It was a triumph of science, and left me in awe of the wonders that nature had revealed. That experience further solidified my conviction that, indeed, nothing is too wonderful to be true. My optimism in the face of uncertainty led me to explore the realms of the unknown and pave the way for modern electrical technology. In my heart, I always believed that the key to scientific progress lay in embracing the unknown with an open mind and an insatiable curiosity. My positive outlook not only fueled my perseverance, but also inspired those around me, as I strived to share the wonders of science with the world. Through this anecdote and countless others, I hope to inspire future generations to approach science with the same sense of wonder and optimism, for it is through such enthusiasm that we unlock the boundless potential of the natural world.
Your experiments with electricity and magnetism laid the foundation for modern technology. However, some argue that your work indirectly contributed to the development of destructive weapons. How do you reconcile the dual impact of your research on both progress and destruction?
As a scientist, I have always been guided by a deep sense of responsibility and a moral compass in my pursuit of knowledge. While my research in electromagnetism and electrochemistry undoubtedly played a significant role in advancing technology and modern society, I am acutely aware of the ethical implications that scientific discoveries can carry. Science is a double-edged sword, capable of both incredible progress and potential harm. The understanding of electricity and magnetism has indeed led to transformative inventions that have improved the lives of many. I have always viewed science as a means to benefit humanity and contribute to the betterment of society. However, I cannot deny that some of these discoveries have been misused for destructive purposes. The responsibility lies not only with the scientists, but also with society as a whole to ensure that scientific advancements are utilized for the greater good. It is crucial for scientists and policymakers alike to engage in thoughtful discussions about the potential consequences of their work. As an individual, I have always advocated for the responsible use of science and the consideration of its wider implications. Ethical considerations should be an integral part of scientific inquiry, guiding our decisions and actions to prevent misuse and harm. While it is true that my discoveries laid the groundwork for technologies that have been used both for progress and destruction, I believe that the positive impact of scientific research should always be our guiding light. It is our collective responsibility to steer the course of scientific progress towards a future that promotes well-being and harmony. In the pursuit of knowledge, we must remain ever curious, yet deeply mindful of the consequences of our actions. It is my hope that future generations of scientists will continue to embrace this balance, fostering a world where scientific discovery is used to uplift humanity and bring about a brighter and more compassionate future.
You are celebrated for your work, but as with any great mind, there must have been times when you faced setbacks and failures. Can you share a specific instance where you encountered a major obstacle and how you overcame it?
Indeed, throughout my scientific pursuits, I encountered numerous challenges that tested both my patience and determination. One particular instance that stands out in my memory is when I was investigating the nature of chlorine. At the time, the understanding of chlorine gas was limited, and its properties remained enigmatic. I embarked on a series of experiments to study chlorine, hoping to shed light on its nature and behavior. However, my initial attempts ended in failure, as I was unable to achieve the desired results. Faced with this setback, I could have easily been disheartened, but my curiosity and passion for knowledge spurred me to persevere. I took a step back, reassessed my experimental approach, and decided to modify my methods. It was essential for me to be methodical and patient, as I knew that answers often emerge from carefully conducted trials. After rigorous adjustments and careful observations, I finally achieved a breakthrough. I discovered that chlorine gas was an oxidizing agent, a finding that had significant implications in chemistry. My persistence and willingness to learn from my mistakes led to this crucial discovery. This experience taught me the value of resilience and the importance of embracing failure as a stepping stone to success. As a scientist, setbacks are inevitable, but it is through these obstacles that we gain deeper insights and refine our understanding of the natural world. My passion for knowledge and my unwavering determination allowed me to overcome challenges and make groundbreaking discoveries. It is my hope that my experiences inspire others to embrace setbacks as opportunities for growth and to remain steadfast in the pursuit of knowledge.
Throughout history, you've been quoted for your famous phrase, "There is no more open door by which you can enter into the study of natural philosophy than by considering the physical phenomena of a candle." Can you elaborate on why you believe the simple observation of a candle can hold such profound significance?
The humble candle, a seemingly ordinary object, yet one that holds a wealth of wonder and knowledge within its flame. You see, in my view, the study of a candle's physical phenomena encapsulates the essence of scientific exploration and the boundless curiosity that drives it. When we observe a candle burning, we witness a dance of transformation. The solid wax turns into liquid, and the liquid transforms into vapor, all of which combine to produce a radiant flame. This simple process holds within it a multitude of scientific principles, from the conversion of matter to energy to the intricate interplay of heat, light, and chemical reactions. In this unassuming flame, we find a microcosm of the intricate and interconnected nature of the universe. Through such observations, we can unravel the mysteries of heat, combustion, and the behavior of gases. The flame itself becomes a canvas for us to explore the laws of thermodynamics and the transfer of energy. Moreover, the study of a candle teaches us the art of keen observation, for it is through attentive watching and thoughtful analysis that we gain insights into the natural world. The pursuit of science, as I believe, begins with simple curiosity and a willingness to question the everyday phenomena that surround us. And so, my enduring phrase encapsulates the idea that even the most commonplace objects hold profound secrets waiting to be discovered. By studying the physical phenomena of a candle, we open ourselves to the wonders of natural philosophy, inviting us to explore the intricate tapestry of the universe, one observation at a time.
You've made immense contributions to the understanding of electromagnetism, but there have been instances where others took credit for your ideas. How did you handle these situations, and what advice do you have for aspiring scientists facing similar challenges today?
The matter of credit and recognition is one that often arises in the pursuit of scientific endeavors. Throughout my career, I encountered situations where my ideas and discoveries were not always appropriately acknowledged. However, in such instances, I chose to focus on the pursuit of knowledge and the advancement of science, rather than seeking personal glory or validation. You see, the world of science is a collaborative and interconnected web of ideas, with each discovery building upon the work of others. I firmly believe that the progress of science is more important than individual accolades. When others claim credit for my work, I found solace in knowing that my contributions were part of a greater collective effort to unravel the mysteries of nature. My advice to aspiring scientists facing similar challenges today is to remain steadfast in their passion for discovery and to persevere despite any setbacks they may encounter. Approach scientific inquiry with humility and integrity, and let the pursuit of knowledge be your guiding light. Share your ideas openly, engage in constructive discussions, and be receptive to feedback from peers and mentors. Collaboration and communication are vital in the scientific community, and through the exchange of ideas, we collectively push the boundaries of human understanding. Remember, true progress in science is achieved through the collective efforts of numerous individuals working together to unravel the wonders of the natural world. Be patient, be methodical, and above all, be driven by genuine curiosity to explore the universe's mysteries. In doing so, you will leave a lasting impact on the world of science, regardless of who may take credit for individual breakthroughs.
Beyond your scientific achievements, you were known for your engaging public lectures. How did you approach communicating complex scientific concepts to a broader audience? And what do you believe is the key to effective science communication even today?
When it came to communicating science to the public, I held a firm belief that knowledge should be accessible to all, not just to fellow scientists. To achieve this, I employed a multifaceted approach that combined simplicity, enthusiasm, and relatability. First and foremost, I recognized the importance of using language and analogies that were easily understood by the general public. I avoided jargon and instead employed everyday examples and relatable metaphors to illustrate complex scientific principles. One of my favorite analogies was comparing the behavior of a candle's flame to the phenomena of electricity. I found that such comparisons helped bridge the gap between scientific concepts and the audience's everyday experiences, making the subject matter more approachable. Another key aspect of my approach was the use of captivating demonstrations. I conducted live experiments during my lectures, which not only added an element of excitement, but also allowed the audience to witness the wonders of science firsthand. By engaging their senses, I could spark curiosity and instill a deeper understanding of the natural world. Furthermore, I was aware of the importance of maintaining an approachable demeanor. I was not concerned with appearing as an unapproachable expert, but instead endeavored to be seen as a fellow learner and explorer. By being humble and receptive to questions, I created an environment where the audience felt comfortable asking for clarification and further insights. To this day, the essence of effective science communication remains unchanged. The key is to present complex ideas in a clear and engaging manner, using relatable examples and avoiding unnecessary technical jargon. Captivating demonstrations and visual aids can still captivate audiences and enhance their understanding. Moreover, fostering an approachable and enthusiastic attitude can help build rapport and inspire interest in scientific discoveries. In the end, effective science communication is about connecting with the audience, instilling a sense of wonder, and empowering them with knowledge. As I once said, there is nothing quite like that moment when a listener's eyes light up, and you know that you have succeeded in igniting the flame of curiosity within them.
In your lifetime, there were also misunderstandings and controversies surrounding some of your ideas. What is one aspect of your work that you feel has been misinterpreted or misrepresented, and how would you like it to be properly understood?
Controversies and misunderstandings are not uncommon in the realm of science, and my work was no exception. One aspect that has faced misinterpretation is my concept of lines of force, particularly in the context of electromagnetism. You see, the idea of lines of force was a visualization tool I used to represent the invisible forces of magnetism and electricity. It was never meant to be taken as a literal physical manifestation of these forces. Instead, I used it as a mental construct to aid in understanding and explaining the behavior of these phenomena. Over time, this concept has been misinterpreted as if I proposed that physical lines existed in the real world, connecting magnets or charged objects. This was not the case, and I regret that it led to confusion. My intention was to present a visual analogy that would help both scientists and the general public grasp the abstract nature of electromagnetic interactions. To properly understand my work, it is essential to recognize that scientific models and visual aids are tools for comprehension, not direct representations of reality. The true essence of my contributions lies in the foundational principles I established in electromagnetism and electrochemistry, which have laid the groundwork for many of the technological advancements we enjoy today. I would be delighted if my work continues to be celebrated for its significance in advancing our understanding of nature's mysteries, rather than being mired in misinterpretation. Science is an ever-evolving pursuit, and as I once said, I am busy just now again on electromagnetism and think I have got hold of a good thing, but can't say. It may be a weed instead of a fish that, after all my labor, I may at last pull up.
As a man of great intellect and vision, you must have had some dreams and ambitions beyond your scientific pursuits. Can you share one personal aspiration that you never got the chance to fulfill, and how does it resonate with you today?
While my life was dedicated to the pursuit of scientific knowledge and the understanding of nature's wonders, there was one personal aspiration that remained unfulfilled. You see, I had a profound fascination with travel and exploration. The idea of venturing to distant lands, witnessing diverse cultures, and marveling at the beauty of our planet's landscapes filled me with great curiosity and wonder. Alas, my responsibilities and commitments to my scientific work often tethered me to my laboratory and the pursuit of knowledge. As much as I longed to explore the world beyond, the demands of my scientific inquiries left little time for such adventures. Today, when I reflect upon this unfulfilled aspiration, it serves as a poignant reminder of the vastness and richness of the world that I could not fully experience in my lifetime. However, my scientific pursuits provided me with a different kind of exploration, an exploration of the mysteries of the natural world. Despite not traversing distant lands, I found solace and fulfillment in unraveling the secrets of electromagnetism and contributing to the foundation of modern technologies. My work allowed me to venture into the realms of knowledge and discovery, opening doors to an understanding of nature that I could have never imagined. In a way, my longing for travel and exploration was quenched by the boundless journey of scientific inquiry, which allowed me to traverse the wonders of the universe, albeit in a different form. While I may not have personally explored far-off lands, I hope that my scientific contributions have inspired others to continue the pursuit of knowledge and exploration, both in the realm of science and the beauty of our world.
And there you have it, my fellow seekers of truth. A whirlwind tour through the life and mind of Michael Faraday, a true titan of science. From candle flames to electromagnetic fields, his impact on the world continues to resonate even today. I hope this intimate who is who encounter has left you as awestruck as it has me. Remember, knowledge is a journey without end, and it's through the timeless wisdom of the past that we illuminate the path to the future. Until next time, remember to stay bold, stay curious, and keep exploring the boundless realms of knowledge. This is David Lee, your offbeat moderator, signing off from Timeless Talks.